When looking at this expression here on the left-hand side, when we have a fraction versus a non-fraction, I'm just assuming that the fraction is the more complicated side. So it's not by much, but I'm just going to pick the left side to work on and see if I can whittle it down to the right side. Again, when in doubt, let's go ahead and convert to sine and cosine. The secant of theta is 1 over cosine. The tangent of theta is sine over cosine. Denominator, cotangent is cosine over sine. And the cosine is, well, that's the cosine. And so when we have a complex fraction like this, my rule of thumb is I want to get rid of the fractions in the fractions as quickly as I possibly can. I'm noticing that I have a c and an s in the denominators. And so my lowest common denominator would be c times s. And if I'm going to multiply top and bottom by c times s, what's going to happen is that all the denominators are going to get canceled out. Both denominators in the numerator and this denominator in the denominator. So when we distribute the c and the s to both terms, let's see what happens here. C times s times the first fraction. That c will cancel with that c right there, and we are just left with s. So c times s over c, that's just s. And then this c cancels with that c as well, and then we get s times s, or s squared. This denominator here, we've got, I forgot to draw a little arrow there. And then this denominator here, we've got c times s times c over s. So again, the s is going to cancel with that s, and then we get c times c. So downstairs we have c squared in the first term, and then this cs times c, that's c squared times s. C squared times s. So let's see what happens here. We can factor out an s from the numerator. We get 1 plus s. And in the denominator, we can factor out a c squared. And we also get 1 plus s conveniently. And so that we can cancel that. So now we just have to make it look like this right side. Tangent, secant. So tangent, I can see I have an s over a c squared. So let's put the sine back in. Let's put cosine squared back in as well. But I need to split this up. We can write this as sine of theta over cosine of theta times cosine of theta, and then which means we can rewrite this as sine of theta over cosine of theta times 1 over cosine theta. So hopefully you can see where we're going here. And then sine of theta over cosine theta, that's tangent theta. And then 1 over cosine theta, that's secant theta. Check.